Hi folks, we're going to take a look at page 376, number 14. So let's take a look at the question here. They tell us that the probability that a person will read a certain advertisement can be modeled by this equation, where n is in days and p at n represents the percentage. Okay, and they want us to know after how many days will the probability be greater than 20%. Right, so let's take a look at this question here. And first, I would just want to talk about this model very quickly, see that it makes sense. So it seems as though 1 here is likely representing 100%, and then we're subtracting this expression here. Now the question is, are more people seeing this over time, or are less people seeing it over time? You'd think that more people would be seeing it over time, which might seem a bit counterintuitive since we're subtracting something. But let's think about what 2 to the negative 0.05 to the n would look like as a function. It would be a decreasing function. So what you're seeing is that earlier on, you're subtracting a bigger number. So say you'd be subtracting, 0.7. 1 minus 0.7 is 0.3, 30%. And as time goes on, you're subtracting a smaller number. So say here you'd be doing 1 minus 0.4, which would leave 60%. So more people have seen it over time. All right, so even though we're doing the subtraction, it does in fact make sense that over time, this whole expression is going to be getting larger. All right, so what they want to know is, when is it going to start being greater than 20%? So I guess the thing to do is to determine when it's going to be exactly equal to 20%. Okay, so 0.2, and then from there, anytime afterwards, more than 20% will have been exposed to the ad. So 1 minus 2 to the negative 0.05, and it comes down to solving this exponential equation. All right. So just to make things easier, I'll bring this expression to the other side, so it'll have a positive coefficient. So 2 to the negative 0.05 n equals 1 minus 0.2 is 0.8. And now I'm at the point where I want to be, where I have a single exponential expression equal to some number. All right. Now, since here we're talking about n having a context, it's the number of days, I'm going to work with log base 10, since I'm going to want an approximation anyways. So I'm going to take log base 10 of both sides. Now again, I'm doing this all in one step, that when I take log of 2 to the negative 0.05 n, I'm going to use the ski-slope rule. So that's going to end up being negative 0.05 n times log 2, okay, because originally this would have been up in the denominator, in the exponent, and then equal log of 0.8. Okay, now I notice here log of 0.8 is going to be a negative number, and then I'm dividing by a negative number, so it makes sense that my final result will end up being positive. So n now, I can just solve for that. It's log of 0.8 over negative 0.05 log 2. All right, so let's calculate this here. So what do we have? We have log of 0.8 divided by, make sure you put that denominator in brackets, negative 0.05 times log 2. Okay, and looks like we get 6.4. Okay, so n is approximately equal to 6.4. And so we can say now that after 6.4 days, more than 20% will be exposed to ad. Okay. Yes, make that a little nicer there. Okay, so let's just recap. So step number 1 was to realize that if I want to determine when it's going to be greater than 20%, I should find when it's equal to 20%. Okay, and we already established that this expression is getting bigger and bigger and bigger. So once I find when it's equal to 20%, any time afterwards should be a higher percentage. All right, so I did that by solving this exponential equation, and then again using log base 10 because I wanted to find an approximation in the end. Okay, that's it for this one.